Hello everyone, welcome to Maths IAC. Here's another GCSE exam style question on energy topic. This one is connected to the topic specific heat capacity, and this one is a slightly tricky question compared to the usual questions you get, but it's well within GCSE limits. So please pause the video and give it a try. When you are ready for the answer, press play and I will explain how it is done. Calculate the amount of energy needed to heat this amount of water up to 95 degrees Celsius. Now we know the starting temperature is 20 degrees Celsius and this is about specific heat capacity. So obviously the formula is E is equal to mc delta theta. E is energy, C is specific heat capacity, delta theta here is the change in temperature. Now you can see the change in temperature is obviously final temperature 95, take away initial temperature of 20, and that's 75 degrees Celsius. So that's your delta theta, right? Now, this question is a little tricky because the question is not only asking about the amount of energy water is already in a copper container. Now, you cannot practically heat just water to 95 degrees because the copper will also will absorb energy because it's in what we call thermal equilibrium. So, the total amount of energy, E total, is the amount of energy needed for copper. So, let's call it E copper plus E total equals E copper plus E water. So, basically, you need to find the energy needed for copper and then add the amount of energy needed for water. So let's do that. So for copper, it's mc delta theta. What's the mass of copper? 600 grams, but it has to be in kilograms. So it's 0.6 multiplied by C of copper is 390. Put it here. Delta theta, we worked out earlier that it is 75 here. So let's put that one here. So this is the amount of energy needed for copper plus energy needed for water. So water mass is 1200 grams. Remember, it has to be in kilograms, so it's 1.2. Specific heat capacity of water is 4200 and the temperature change is 75. Now we just need to put this in the calculator to get the answer. So here we get 395,550 joules. This is the answer for the first part. Second question, explain how and why. Now look at the command words, really important. Explain how and why the answer to part 1 above differ in real world. Now, in fact, in real world, when you start heating this copper container and water in it, obviously heat will start to dissipate to the surroundings and you can't really stop it. So although theoretically you need only 395,550, you'll definitely need more than that to compensate for the energy loss to the surroundings. So here's how you can put it into words. In reality, you will need more than 395,550 joules. As this system is not 100% efficient in heating, energy is lost during the heating process.